Hi everyone, my name is Veronica Viler and I'm a Horticultural Research Assistant at the Botanic Gardens of Sydney in the Australian Plant Bank. I'd like to acknowledge the Dharawal people, the traditional custodians of the land I work on, and pay my respects to elders past, present and emerging, and extend my respect to other First Nations people watching today. My talk will focus on two important ex situ conservation collections held at the Australian Botanic Garden: Rhodanmnia rubescens or scrub turpentine and Rhodomyrtus psidioides or native guava. The collections were established in collaboration with Saving Our Species as part of their emergency response project. The aim of the project was to collect germplasm before it was lost in the wild due to their extreme susceptibility to myrtle rust. Genetic testing by the Research Centre for Ecosystem Resilience has determined that both collections are representative of the diversity in the wild, which is important for long-term conservation. Rhodomyrtus psidioides once occurred from Broken Bay, approximately 90 kilometres north of Sydney, to Maryborough in Queensland. It was typically found in coastal to subcoastal areas. However, it also occurred up to 120 kilometres inland in the Hunter and Clarence River catchments and along the border ranges in New South Wales. There is no documented evidence of resistance to myrtle rust for this species, and it is expected to be extinct in the wild in one generation. Rhodanmnia rubescens typically occurred in coastal districts north from Batemans Bay in New South Wales to inland of Bundaberg in Queensland. It was found in littoral warm temperate subtropical rainforest and wet sclerophyll forest. Initial testing has shown some resistance for this species and work is underway to explore this further. Once again, it is expected to be extinct in one generation, only 14 years after the arrival of myrtle rust to Australia. So now to the good news. Rhodomyrtus has proven relatively straightforward in terms of timing and ease of propagation. Rhodanmnia took a little longer to pinpoint the timing for propagation, which is in winter. Fortunately, both species have a propensity to sucker, so where a parent had no suitable material for cuttings, excavated suckers have provided another option for propagation. Suckering also got us thinking about the possibility of root cuttings where there was no above ground material available, and some early work with nursery plants looks promising. All material was collected and then sent express post. A large proportion of the material for both species came in with visible pustules or lesions, but all material was treated as infected regardless of visible symptoms. Initially, propagation was carried out in the lab in a fume hood to reduce the risk to the nursery collections. New wild collections are still processed in the lab sometimes, although it is possible to safely process cuttings in a nursery environment. Both cuttings and suckers are treated with a systemic curative fungicide before being moved into the propagation glasshouse or broader nursery, and then monitored closely for a period of about 4 weeks. Generally, no follow-up treatment is necessary. The collections currently represent 95 genets across the two species and approximately 1,000 plants in total, although that figure is dynamic depending on the time of year. Both species do well in cultivation and repropagation is necessary roughly every 18 months. This image shows the first generation in the background and the first repropagation done 2 years ago in the foreground. Besides myrtle rust, both species are also susceptible to pests such as mites, thrips and scale, to name a few. I think it's important to say that in the nursery environment, myrtle rust should be viewed as another disease to be managed. Educating ourselves on what to look for, how to respond, and being prepared in advance can greatly reduce the risks and the anxiety. I'm often asked whether we've noticed any signs of resistance in the collections, but the purpose of the core collection is to secure the material, so we would never allow an infection to continue untreated. The collections provide the material needed to produce cutting-grown plants, seed and seedlings for further research. Myrtle rust is managed using a combination of regular monitoring every couple of days, cultural practices and fungicide use when appropriate. Regular monitoring ensures that when myrtle rust arrives, the situation doesn't get out of hand. Cultural methods such as adequate spacing for airflow, pruning to control the size of the plants, considering the type of irrigation, and good plant and equipment hygiene all reduce the risk of infection and therefore reliance on chemicals. Having said that, sometimes spraying is unavoidable. The past 3 years have been exceptionally humid and wet due to La Nina, and there were times when regular spraying was necessary. Having the right personal protective equipment, fungicides, and minor use permits on hand ensures that spraying runs smoothly. It's also important to monitor weather conditions generally and be familiar with microclimatic conditions at your site. Fungicides are applied on a rotating basis to prevent the disease from developing resistance to treatment, and an understanding of the modes of action for each chemical is essential, as well as training in application. We were happy to discover that 12-month-old cutting-grown plants will flower and fruit, and in fact, potted plants are incredibly productive. To date, around 60,000 seed from 39 maternal collections have been banked for the 2 species. Prior to these collections, we were unable to establish wild collections of either species due to the impacts of myrtle rust. As well as seed for storage experiments and banking, the collections have provided material for numerous research, including metabolomics, cryostorage trials, myrtle rust assays, and the establishment of tissue culture collections. Maximising the use of plant material ensures more bang for your conservation buck. For example, usual seed banking procedure is to run a germination trial with a sample of an incoming collection. Rather than discarding the seedlings that were produced, they were grown on and used for myrtle rust susceptibility testing. In the case of Rhodanmnia, some of the seedlings demonstrated the same resistance that the parent material had displayed in earlier testing, which was very exciting. Herbarium vouchers capturing flowering and fruiting have also been made from the collection and ensuring that information is captured where the wild plants may no longer exist. Holding the entire collection at one institution was identified as a risk, and work is underway to disperse clones to several other botanic and regional gardens. Dispersal also enables other institutions to conduct their own research with a ready supply of plant material and provides the opportunity to observe how the plants perform in different environments. We believe these collections are a case study for other myrtle rust susceptible species, and work is underway for a similar collection of Rhodanmnia maydeniana, which is similarly threatened. Planning is also in progress to explore resistance breeding for Rhodanmnia rubescens with a view to eventually returning plants to the wild. Thank you for listening.